Okay, Calculus 2. I want to tell you about what happens when you're doing integration by parts and you get stuck in an infinite loop. So this happens when you have something like the integral of secant cubed of x dx. So for this integral, um, what you want to think about is um, this is equal to the integral of really secant of x times secant squared of x dx. Now, does one of those look like the derivative of a function you might know? And the answer is yes. Secant squared is the derivative of tangent. So then that means we'll do u equals the secant of x dx. So then du, derivative of secant, is secant tangent. And then I've got dv is secant squared of x dx. So v is tangent of x. So then this is going to be equal to uv minus integral v du. So then that's going to be uv is secant tangent minus the integral of v du. V du is secant of x. You got a secant of x and then two tangents. Tangent squared of x dx. Okay, so now when we're thinking about our trig identities here. So tangent squared of x is sine squared over cosine squared, right? And so if I were to say add 1 to that, that's sine squared of x plus cosine squared of x all over cosine squared of x, which is equal to 1 over cosine squared, which is secant squared of x. Okay, so that means that this is equal to tangent then is secant squared minus 1. So secant of x tangent of x minus the integral of secant of x times secant squared minus 1 dx. So then this is equal to secant of x tangent of x, and then I've got minus minus, so then plus integral of secant of x, and then minus integral of secant cubed of x. That's dx, and that's dx. Okay, I'll solve this one next. This one has its own trick. So this is equal to secant of x tangent of x. Now maybe I'll just do it over to the side. Let's go over here and just do a little quick. If we're doing the integral of secant of x, I forgot that I needed to do this beforehand, but here we are. So this one has a little trick, and if you do secant of x times secant plus tangent of x, I don't know if I have enough room. Maybe I'll do it over here. Do it over here. Integral of secant of x dx is equal to the integral of secant of x times secant of x plus tangent of x over secant of x plus tangent of x dx. That's the trick for doing this integral. So that's equal to the integral of, I'm going to do multiply across the top and I'm going to put it in, and then I'm going to put the bottom in the opposite order. So integral of secant squared of x plus secant of x tangent of x. And write the bottom in the opposite order. Tangent of x plus secant of x dx. Well, if you look at this, the derivative of tangent is secant squared. The derivative of secant is secant tangent. So this is equal to, if u is tangent plus secant, du is the top. So this is equal to the natural log of absolute value of secant of x plus, I'll do it the same order as the bottom, tangent of x plus secant of x plus c. So we know the integral of secant. So I'll do that here. So plus the natural log absolute value of secant of x plus tangent of x minus the integral of secant cubed of x dx. So here's my problem. I started off with the integral of secant cubed, and I did all this work, and I got back to the integral of secant cubed. So at this point, maybe I should just throw up my hands and quit. But no, I can do this. If I add integral, move this guy. This guy has been equal to everything. So move it, so rewrite it again. Then add secant, the integral of secant cubed to both sides. So if you add the integral of secant cubed to both sides, you have 2 times integral of secant cubed of x dx equals secant of x tangent of x plus the natural log of the absolute value of secant of x plus tangent of x. And then somewhere in there, I should have had a plus c because of, yeah. And then I just divide by 2. So the integral of secant cubed of x dx equals 1/2 times secant of x tangent of x plus the natural log of absolute value of secant of x plus tangent of x plus c. So that's what that answer is. And so what's the moral of the story is that if you get back to where you started, but it's negative, you are done. You just got to add it to both sides and divide by 2. And that's one of the tricks that might show up in one of the homeworks for this section. So I just wanted to make sure everyone was aware of that.